my talk is about basically securitizing your websites. So if you have something valuable that you want to make sure doesn't get stolen, we want to generally encrypt that sort of data. So what I'm going to talk about is how to pass a security audit. I won't talk about how to keep your actual server safe because that's kind of out of the scope. This is just keeping the information safe on the wire. So if you want to figure out how to secure your actual server, there's a link on this page. And if you want to get this PDF, you can just clone this GitHub repo. Okay. And I've created kind of a very minimal website here. You'll probably experience a little bit of pain because Nginx doesn't support relative paths in its configuration file, so I just have like my own name in there, and when you see it, you'll be able to edit it. Okay. So this is what you're basically a pretty standard Python idiom here. We're just installing the requirements, acquiring a root shell, and sourcing it. Okay. So when you want to secure your website, the first thing you have to do is generate Ssl certificates, and the way you do that is you do this OpenSSL. Does everybody know about OpenSSL? I think most likely.
Sorry, can you read that repo name?
Oh, yeah, sorry. The repo is github.com, N.A. Thompson, Django HTTPS.git. So let me make this a little bit bigger. Yeah. Django _ HTTPS. Yeah, so what you want to do, the first thing you need to do is just generate an RSA key. So you do OpenSSL, gen RSA, and I wrote this here because every time, I need to secure a website like once every 4 months, and every time I do it, I forget. So I wrote these commands here just so that I could personally go back and not trudge through a million DigitalOcean articles trying to figure out which one I actually need. So what this is doing is it generates a private key of 4096 bits. 4096 bits is now recommended. A lot of places use 2048 bits. It depends on what you're trying to encrypt. This is not going to slow you down too much to use 4096 bits. I've talked to people who are securing really, really valuable information, and they use 16,000 bits for their RSA key, and they regenerate them every day. So I'm just trying to secure stuff that, you know, if it became insecure, I would lose my job, but it wouldn't be like a bigger deal than that, right? It wouldn't be a national security incident. So that's the sort of, once you generate your key, you hash it, and you create a certificate signing request of this CSR, and that's where you put in your your organization, where you're from, who you are, and then you verify it. And I got my SSL certificates from Namecheap for $5 for this talk. And so what you do is you just copy and paste it into the Namecheap menu. Okay. And then you're going to go through some sort of rigmarole with your certificate provider, and they're going to send you these certifications. So since I got a $5 certificate, I got it through Komodo, and they sent me this zip file that had all these files, and you need to then create a bundle so that your server can find it. It can't find all these together. And it's a real pain that they have to be in the exact right order. I don't know what if you use a different certificate authority, you're going to have, this won't work, obviously, but this at least will work for one. So my example is just Django, Gunicorn, and Nginx. And I think a lot of you guys probably know this is just the web server gateway interface. And when we go through this, you'll see that you can do a lot of your security settings through Django, or you can do them through Nginx. And so we're gonna focus on Nginx because it's a little less painful. But if you're a developer that wants to do security settings through your Django project, you can, but just make sure that further upstream you're not going to set these sort of configurations twice. Okay, so that's how you do it in Django Secure. And this is what you would put in your Nginx configuration file. So I'll just go over to So in this thing here, this is just an Nginx configuration file. It listens on socket 80, and then it does a permanent redirect to the HTTPS. And then we also listen on socket 443, and we have our certificate here. So we have our bundle cert, and then our private key. Okay. And this is actually how you start the website up. Nginx has a default configuration file, which I generally don't edit. I like to keep my configuration files in my project. So this is how you start the website. Okay. Now, Nginx has a default security configuration, and if you then go and test your security configuration SSL by SSL Labs, this is a kind of a security auditing tool. So I can go, I'll show you. So here I've run my website on it, and it shows various things about it's basically grading your website. And I really recommend that you use this tool if you're going to do any sort of HTTPS stuff, because every 2 weeks there's a new vulnerability that's found. And when you find a new vulnerability, basically somebody can take you for all you've got. So you might want to have somebody do an automated test with this tool. So we can also do just PyTexas.org. PyTexas.org doesn't have a lot of hugely valuable info, right? The actual payment card is run by Stripe on a different website. So we, of course, don't need to put a lot of effort into securitizing it. But if you do look at it, it'll show you a lot of kind of the effort to getting from your default Nginx configuration to a very secure configuration, which is what I have on this example website. Okay. So when you go through this, it's going to show you a lot about your keys. It says, okay, you have a 4096-bit RSA key, and then it's going to show you your certificate chain, and it's also going to show you your protocols. So these protocols here. TLS is a protocol that was made, well, it's been a continuing protocol, but TLS 1.2 I think came out in 2008. And it's it's a set of Cipher suites that are agreed upon that result in a secure configuration. So as we look through this, okay, I should get back on track here. But if you're trying to secure your servers and you have clients who are security conscious, which are lots of people, generally their IT department will call you and say, why is your SSL Labs grade so low? And if you don't have a good answer, they're going to not do business with you. So in order to improve your grades, what you can do is you can, in your Nginx conf, you just get rid of support for TLS v1, TLS 1.1, and only support TLS 1.2. Okay. So there's a cost to doing this. Maybe if you're running like a social website like Facebook, you don't want to do this because actually there is what's called Cipher suite negotiation. So in Cipher suite negotiation, there's a set of protocols. Let's say my browser knows how to encrypt this data using elliptic curve Diffie-Hellman. And my server doesn't know how to encrypt data using elliptic curve Diffie-Hellman. So then they say, okay, we can't agree on elliptic curve Diffie-Hellman. Maybe I can encrypt using RSA. And then the browser says, okay, I can encrypt using RSA. And then they agree on that. And that's the protocol that you're going to use for the rest of the session. Now, if you get rid of TLS1 and TLS 1.1, what happens is called a handshake failure. So sometimes you'll go through the list of protocols that your browser supports and the list of protocols that your server supports, and they won't find one in common. And when that happens, your users do not get a good error message. Okay, it doesn't say like, oh, your browser doesn't support these protocols. Basically what happens is they just get a blank page, and they have no clue why that happened. And so if you're willing to make some people angry in order to improve security, then this is a way to do it. So you can see on the SSL Labs test, they do what's called a handshake simulation. So this Android 237 device, it tries to talk to my website using the protocols it knows about, but since my protocols are all strong protocols and Android 2.3 doesn't have support for those strong protocols, they can't talk to each other. Okay. Whereas Android 4.4 and 5 are, they do have support for TLS 1.2, and you can actually see the protocol that they agreed on when they negotiated. So during the handshake simulation, this Android 4.4 found, okay, well, I can do key exchange using elliptic curve Diffie-Hellman and authentication using RSA, and then the actual symmetric key protocol is AES 256 in this what's called Galois counter mode. Okay, we can't communicate with Baidu at all. We can't communicate with a lot of Internet Explorer browsers, and we can't communicate with any Java clients due to that. Whereas here on PyTexas.org, since the security requirements are not all that dire, you can look and see what sort of negotiation happened, and you see that basically PyTexas.org can communicate with everybody. Except IE6. Okay. So there's a trade-off between the accessibility to your customers. If you don't know who your customers are, you might not want to disable support for TLS 1.2 or TLS 1.0 and 1.1. Okay. But you need to understand that in a year they're going to start deprecating support for TLS 1.0. So if you're engaging in any sort of credit card payments or stuff like that, which you hand roll, you're going to lose your PCI compliant status on the 30th of June of 2016. So I recommend just getting it over with and making sure that you're using these strong protocols. Okay. I also got rid of TLS 1.1, and that's because TLS 1.1 was superseded by TLS 1.2 after a period of 2 years. And so basically no one has support for TLS 1.1 that doesn't have support for TLS 1.2. In fact, with the server, you can see what sort of protocols you support. So I can say OpenSSL ciphers minus V. Okay. And you can see what sort of protocol this is. So this is AES 128 in Galois counter mode, and it's a TLS 1.2 protocol. Its key exchange is RSA, its authentication mode is RSA, and its bulk encryption is AES in Galois counter mode, and the message authentication is essentially inherited from the AES. Okay. So if I just grep through this, I say, all right, what if I don't want any protocols from SSL v3? And SSL v3 is totally broken. So these are what I'm left with. These are all the protocols that I can use. Let's see. Sorry if you can't. Tell me if you can't see this. I need to make it a little bit smaller just so we can see what's going on here. So now I'm left, if I get rid of SSL v3, then I can see there's no protocols there that are from TLS 1.1. Okay. So if you want to just go for improving your SSL Labs grade, you need to pick protocols from the set of TLS 1.2 protocols. Okay. So you need to restrict yourself to a subset. So you can see that I have how many protocols that are just TLS. So I have 28 protocols that I can use on TLS 1.2 using my version of OpenSSL. Some of those, say the 128-bit protocols, are regarded as weak. So if we just remove support for those, hopefully this will get it. Then we have all these protocols left. So now we're down to 14 protocols that we can use. Okay. So once I do that, I can put these names in my Nginx conf. So I can say, okay, I take this elliptic curve Diffie-Hellman thing, copy and paste it into I forget whether it's the default or the Nginx conf. Oh yeah, it's the Nginx conf. I put it in my Nginx conf. So these are the ciphers that I'm going to support here. All right, so we get rid of all the 128-bit ciphers, and then I've decided to support only forward secret protocols. So we'll go into what a forward secret protocol is in a second. I think we've actually talked about Cipher Suite negotiation here. But the Cipher Suite, for a Cipher Suite you need 4 components. So you need to be able to exchange public keys, you need to get private keys from your public key algorithm, and then get a bulk encryption algorithm. You need to do some sort of message authentication code, like hashing it, and then authenticate yourself with your, say, your certificates. Okay. Let's see. And we've somewhat been going over this, but so OpenSSL, ciphers. Let's see, what's that? Yeah. So this is all the ciphers we can support. Okay. And we need to understand that somehow. We need to look through, if we look at, say, elliptic curve, well, let's see, elliptic curve Diffie-Hellman, we can go here. And basically this is going to tell us a lot about what that kind of acronym means. It's saying, all right, it's a TLS 1.2 protocol, its key exchange mechanism is elliptic curve Diffie-Hellman with elliptic curve digital signature algorithm, and then it's authenticating using elliptic curve Diffie-Hellman, and its symmetric protocol is AES, and its message authentication is SHA-256. Okay. So if I only supported, say, 2 protocols here, what this would say in the Nginx configuration is, all right, this first one is the one that my server prefers. This is, I think that this elliptic curve Diffie-Hellman with RSA and AES-256 with the SHA-384 hash is the most strong algorithm, and that's the one I'm going to tell the browser to use. But if the browser doesn't support it, then I'm going to tell him, oh, well, I'll go and use this other protocol here. But if that browser doesn't support it, then they won't be able to communicate with each other. Okay. And so it's kind of an interesting question. What Cipher suites does browser support? And so if you just click on that link that I put in the PDF, you can see, I think I did this with Chrome. Maybe I did it with Firefox, I'm not sure. But it will say, oh, here's all the Cipher suites that your browser supports. Okay. You need to make sure to sign your certificates with SHA-256 because Google is going to stop trusting SHA-1 hashed certificates in about a year, I think. So actually right now, when you go to a website, a TLS website, that has its certificate hashed with SHA-1, it is putting up a warning. Okay, so it will not be long before you have to use SHA-256 or one of the stronger SHA protocols, such as SHA-384, SHA-512. And the reason why they are pushing towards moving away from SHA-1 is that they think that relatively soon we're going to start seeing hash collisions on SHA-1. So if you ever followed the Iranian nuclear reactor thing that the NSA did, they basically forged a certificate in order to get Microsoft to be able to load their virus. And the way they did it is they found a hash collision on MD5. Once they got the hash collision, they could then convince the Microsoft operating system that this was a legitimate piece of software. So once you start getting hash collisions, very bad things can happen very rapidly. So let's see. Oh, so this is a very new attack. This is kind of the reason why you want to use these tools like SSL Labs to validate your security of your website on a continuous basis. Because it turns out that there was a hole in some of these weaker protocols, and they were actually unencrypting a lot of data. And so there's some information on there, but I'll describe to you this attack. So I'm just going to review Diffie-Hellman key exchange really quickly. So your server has a prime P, and then it has a group generator, and it picks this random number A. Okay, and then you, over the network, on the server you compute due to the A mod P, and then transmit that number. Okay, then the client chooses another random number and computes G to the B mod P, and then what you have at the end is by modular exponentiation you can get a shared public key, or a shared private key for your symmetric protocols. Okay, and the idea here is that if you can do modular exponentiation very fast, but there's no known way to do discrete logarithms, which is the inverse operation, without a quantum computer. Okay, so this is why people get excited about quantum computers, is because they can invert modular exponentiation rapidly. Okay, Diffie-Hellman key exchange has a very nice property which is called forward secrecy. So if I'm listening to encrypted traffic, I can just take a bunch of it, right, for years and years and years. And then one day I figure out a way to get into the server's private key. If I'm not using a forward secret algorithm, I can take the server's private key and I can decrypt everything I've been listening to for the past 3 or 4 years. With a forward secret algorithm, I can't do that. So here's the way that forward secrecy works with the Diffie-Hellman key exchange, which is it has this random secret. So it generates a random number, and when that number is random, it means I hold it in RAM, and then at the end of the session I get rid of it. And so if the NSA subpoenas my Diffie-Hellman keys, I say, well, here it is, but all these random numbers were generated along for years and years and years, and I don't know what they were. So you can never decrypt. Even if you give a subpoena to somebody that's using a forward secret algorithm, you can't decrypt that traffic. So the problem that Diffie-Hellman key exchange is currently having is that generating primes is somewhat computationally expensive. You have to do, say, Miller-Rabin primality testing. So what happened is that for Apache, they just gave you a prime, and they gave everybody the same prime. And so what they found is that 92% of these Apache sites were using the same prime, and it was a weak prime. It was about 512 bits long. So that becomes a target for a lookup table, right? When everybody's doing the same thing, then it makes it very attractive. So if we're supporting, say, these SSL v3s, these TLS10 protocols, then this guy can get in the middle. You can perform a man-in-the-middle attack. Maybe my browser says, oh, I want to use this high-grade protocol. This very, during the Cipher suite negotiation, he says, I want to use this very secure protocol. But somebody gets in the middle and he changes that message to, I can only deal with SSL v3. I can only support these really weak protocols. And so then the server responds back with a very weak negotiation. Okay, and so then they agree on that. And so that is how a lot of people suspect that NSA was decrypting a lot of the traffic on the wire last year. So they were doing downgrade attacks, basically getting in the middle of everybody's stuff. And downgrade to 512-bit Diffie-Hellman key exchange. And then if you solve a 512-bit discrete logarithm problem, well, you can do it. It takes about a week. But the thing is that since everybody's using the same prime, you can do it for a week once, right? If you have a big compute cluster, you can compute for a week once and then decrypt everything. So the way that you get around this is you generate your own prime on your server. So this is how OpenSSL does it. So you say, I want a Diffie-Hellman parameter. It needs to, the group generator needs to be 2. Validate it and put it in the file dhparam.pem. And then you add this to your Nginx configuration file. Okay, and you can kind of see how long this takes. Yeah, so I'm not going to do this whole calculation, but it tells you it's going to take a long time, and it does take a long time. So actually this one seems to be going along pretty well. In any case, I've already generated this. It'll be 5 or 6 minutes before this finishes, but once you do that, your SSL labs grade will be very high. Okay. Now, there's other things other than just your key protocols that are necessary for security, which include HTTP headers. So there's a new attack where a server would send all traffic over HTTPS. Okay. Someone would get in the middle and say, oh, the browser's sending this information over HTTP. And then you would put your credit card in onto HTTP traffic. And what would happen is the request would fail, right? But you've already sent your credit card details unencrypted. So the Internet Engineering Task Force came up with a kind of a hack to get around this problem, which is they say, okay, well, we're going to set a header that says everything that comes from this server is going to be HTTPS. And if you get a request from this server that is via HTTP, that means that you're a victim of a man-in-the-middle attack. Okay. And so there's actually a guy who wrote a piece of software. You can find that by clicking this link. He wrote a piece of software to engage in this attack. And basically it allows you to just screw people. I mean, you can screw people with this thing. So I highly recommend that you set this header if you're taking payment cards or letting users upload data that they regard as sensitive. So once you set this HTTP header, this HSTS header, then if they go to your website and it's not being served over HTTP, you're going to get this message, and this message is pretty dire. It's saying you're probably a victim of a man-in-the-middle attack right now, and you can't proceed. Now, of course, the users can clear their browser cache and then get past it, but it would be probably a bad idea. So this is kind of another hack, but the interesting thing is, in order to set up HSTS, is you just add this line into your Nginx configuration file. You say, add this header to say strict transport security, which means I'm only going to transmit data over HTTPS. And this max age thing says, I'm going to be serving over HTTPS for 63 million seconds or something like that. And all my subdomains are also going to be serving only over HTTPS. Okay. And that should be in, I think that's in the Nginx conf. So let's see. Oh yeah, so this is our Diffie-Hellman prime that we put in there, and no, it's on the right. So this is how to set that header. It's in the server section of your Nginx conf. Okay. All right, and you can also set this header directly through Django and Python if you want. I don't necessarily recommend that, but you can do that. Nginx doesn't have the best debugging information. If you have a syntax error in that HTTP header, it just won't get set. So the way that I validate that I've actually set this header is you can do curl on it. So I can just do curl -v -i. And let's see, there is our header, strict transport security. So I find it much easier to validate using curl than to just kind of debug the Nginx configuration file. All right. And I think I've actually gone over this, or the strong key exchange. I wanted to give a shout out to a project called Let's Encrypt. it seems like everybody regards these certificate authorities as annoying. They're trying to really monetize the whole process of generating certificates and trying to get you to go through these really elaborate authentication procedures with a bank notary. And really that stuff is just kind of unnecessary, right? It's just a money sink. So Let's Encrypt is a project. They've got active trusted certificates that are free. And so if you just use this Let's Encrypt place, you don't have to pay anyone. This is a new project. I downloaded it yesterday. It's a Python project. And it takes a lot of this OpenSSL boilerplate out of the mix. But it's very buggy. So, and not all browsers trust their certificates yet, but I think that they're going to be taking over quite a bit. Okay, so I wanted to talk about clickjacking, which is a pretty gnarly attack, which is, let's say that you have a web page and somebody takes your web page and overlays it in a frame, right? So maybe you have an eBay web page and it says, buy this car now. And then they take your web page and overlay win a free iPad over the buy it now button. And so if you click win a free iPad, it will render through that frame and then you will click buy this car now. And so people can get really, if you're logged on, then you're going to be owning a new car. So this is one of, I wanted to read this to you, which is just, it says, one of the most notorious examples was an attack against Adobe Flash plugin settings. By loading the page in an invisible iframe, an attacker could trick the user into altering the security settings of Flash, giving permission for any Flash animation to utilize the computer's microphone and camera. So it's a pretty, they can really do things you don't like, and it's very, as a user, it's very hard to detect this, right? I mean, basically any ad is bait, right? A lot of these ads are rendered in frames. You have no clue. You're not going to sit around and validate the actual HTML of all the ads on the internet, right? It's just not going to happen. So I think it's just a matter of politeness that when you do this, when you're serving a web server, you should just say, I'm not going to allow any of my stuff to be embedded in a frame. And so to do that, you just set an HTTP header. It says, deny my website to be embedded in somebody else's frame. Okay, so you can see that with curl, I've actually set this header. And if I look in my Nginx configuration, I have it there as well. Okay. So content sniffing is somewhat, I think it's gotten better. Microsoft made an algorithm to guess the type of content that was being uploaded and downloaded on the internet, and that allowed people to basically exploit bugs in the content sniffer. So they would say, somebody would think they're downloading a JPEG because, say, the content sniffer just used the file extension, but really it's just some malicious script. And to get around this, you can just tell Internet Explorer not to sniff content. You just set a header. It's quite easy. So this is probably the last thing I want to talk about, which is certificate authority fraud, which is, this is not a problem for people who are not super important, right? If you're super important, you should worry about certificate authorities issuing certificates for your website. For my websites, I don't do this because I'm not super important, but say the National Iranian Certificate Authority issued a certificate for whitehouse.gov. What happens? Well, immediately, anybody who goes to whitehouse.gov and resolves to the Iranian Certificate Authority will have a trusted certificate that is then served by a server that is not White House, that is not the White House, right? So what happened is there's been a number of incidents of this happening. The Iranian government has hacked the Dutch Certificate Authority. They issued certificates for Microsoft.com and then built like a huge website with login pages and everything. And so anybody in Europe resolved to the Dutch Certificate Authority that went to Microsoft.com and logged in lost their credentials. Right? They were just completely stolen. And an Iranian guy also hacked Komodo and issued certificates for just all sorts of things. I don't think he had actually the resources to make convincing websites that were fraudulent, but he did get some people. This guy is actually quite a character. I recommend you read that that article that is linked there, because he was actually claiming he could factor 4096-bit products of primes, and that he had the experience of like millions of years and stuff. He was really, really funny guy. Of course, that's why everybody doesn't trust Komodo anymore and thinks it's a crappy certificate authority. The way he actually got in to issue certificates for Komodo is he used the CEO's email address and then went through the dictionary and guessed every word in the dictionary, and he got in. So it wasn't rocket science what he did. But to deal with certificate authority fraud, there's a thing called public key pinning, which means I'm going to hash my private key. I'm going to say generate a SHA-256 hash of my private key, and then I'm going to add that as a header to my HTTP request. And when that happens, the browser is going to say, I'm going to save this hash as a cookie, and when I go back there next time, if that hash doesn't match, then I'm probably in the midst of a certificate or authority of fraud event. Okay. And so in order to generate these hashes of your public keys, you use this kind of horrible OpenSSL command line. You need to, yeah. Right, so you basically take your key, render it as a pub out, and create a SHA-256 digest of it, encode it as base 64, and then you put it as this header. And in case one of your keys gets compromised, generally you want to create a backup key as well, and you'll pin two public keys. You'll pin your active key, and you'll pin a backup in case somebody compromises your server. Okay. And also, if you're using Django, you can use what's called the Pony Checkup, which is really cool. This is just another sort of security validation tool that looks for Django-specific security vulnerabilities, such as you say, let's see. So this is a Django thing running in debug mode. It's a security vulnerability, and so Pony Checkup will look at that for you. And some other things that you want to do, honeypot the admin page, and then Django Axes will actually do user lockouts after failed attempts, which is really important. You pretty much have to have that for any website that has anything valuable on it. So I think we got 5 minutes left, so I'll take questions now. Yeah.
So as a web user and as a website owner, what are general steps that I need to do to improve security?
As an owner, you don't have to do too much. You need to generate your certificates, get them validated by a certificate authority, install them on your server, and then set some HTTP headers, such as just your public key pinning, your clickjacking, your X-frame deny. And as a user, to improve security, there's not really a lot you can do. I mean, there's an attack called packet injection. Somebody gets in the middle, they will, even if you're Microsoft.com or if you're Rackspace, if you're putting stuff over HTTP, if somebody gets in the middle, they can inject anything into your traffic. And actually, packet injection is so easy that they're assigning it as homework at U Michigan to create a packet injector. So all they need is just access to the wire. And they can put anything on your computer, run any JavaScript.
So the key to security as a user is use HTTPS.
Well, yeah. There's nothing you can do though. I mean, you can't force other people to start using HTTPS, right? Most people are under the impression that if they have a website that's just serving GET requests, like a newspaper website, they think that they don't need to encrypt anything. Well, in a sense, they're right, but your users can still be victimized from just the process of HTTP. And they think, oh, I'm on a trustworthy website, but it doesn't matter if the website is trustworthy. The entire ecosystem needs to be trustworthy. So, yeah, there's nothing you can do, just hope.
How about if you use a virtual machine as a user?
Well, yeah, I mean, a virtual machine will kind of make it so that any sort of malicious scripts can't escape the virtual machine. But it can still, do like cross-site scripting. If you're living there, then your data gets there, right? I don't see any way of avoiding that.
So you're saying that even if every time I go to some website, I do HTTPS, and then website saying that I can be a victim? Or how much more difficult will I be a victim if I use HTTPS in my browser and if I don't use it?
Well, you have no choice over whether the server is serving it encrypted or not. But let's say that I go to the Washington Post, which is encrypted. Then I know that no one, since it has a message authentication scheme involved, I know that nobody has injected malicious scripts. So that's nice. Of course, the Washington Post allows like all sorts of trashy advertisements that are coming in as just given to you. So there's just not a lot you can do, really. Unless you just want to make the internet completely inconvenient to yourself. You just kind of accept the risk. So, anything else? Okay, I think there's another talk here in a bit, so I will